Hi thinkers, welcome to the Data Structures in Python course on thinkxacademy.com. In this tutorial, we are going to study the Dijkstra's algorithm in Python, which is to find the shortest path when you are given a graph data structure. So we have already covered graph data structure and algorithms like the DFS and the BFS algorithms. Now this tutorial is very important for all the beginners who are really interested in a lot of competitive programming problems, because in this single problem we are going to cover a lot of important things. This algorithm uses greedy approach, so we will also learn that, and I will also share some of the interview tips that will help you understand where the optimizations in an algorithm can be done, and an algorithm can be made optimized by the time complexity, right? So let's start with the algorithm. Here we are given this graph data structure. These are the nodes A, B, C, D, E, F. These nodes have, you can see, edges which are actually weighted edges, means that they have some distance in between them. And you can see I have this A node as the starting node, and I am assuming that F node is the destination node. So here the source is A and destination is F. So what the interviewer will ask you, the problem that this algorithm will solve is to find the shortest path from the starting node to the terminal node. So here we want to find out the shortest path and the shortest distance from A node to the F node, right? So let's see how Dijkstra's algorithm can be used to do so, right? So the idea of Dijkstra's algorithm is very simple. What we are going to do is, first let's start with the explanation part. So here we are going to start with the 8th node, which is assigned a cost of 0, because it actually you can see this is actually the cost. So for each and every node we are going to assign a cost, and we will see what is the significance of that cost. So A has a cost 0, which means it actually cost nothing to reach 0, because it is actually the starting node. And then you can see that except A, every node has an infinite cost. You can see they have this infinite cost, and which means that we have not yet explored the cost of reaching from the starting node to that node. We don't know the cost at this point. So we just assigned it the maximum value, which is infinite, and we know that we can achieve this in Python using the sys library, and we have the max size function which can actually give us the maximum infinite value, right? So let's see how the algorithm will proceed. So we have the F node as the terminal node. So here I am going to write that this is going to be the terminal node. Alright, so the first thing is we need to find out the neighbors of the first node. We are going to start with the 8th node. A node has two neighbors, which is B and C. The first thing I'm going to do is, once we have the adjacent nodes, right? So I'm going to write step 1 here, which is to find the adjacent nodes, and we know that adjacent nodes of A is actually B comma C. And obviously we can use a dictionary to find that out also. We will see that in Python also. So adjacent nodes are B and C, and what I'm going to do is I'm going to find out the cost of B and cost of C, right? So once we have find out the neighbors of A, we are going to find the cost of each neighbor, right? And the cost of each neighbor is actually going to be the cost. So here we have, let's say we want to calculate the cost of B, and B is actually the it's not just the cost of B, it's actually the cost from going to A, from A to B, right? So if I want to go from A to B, what I can do is I will have to first see that actually B is a neighbor of A. So first we will have to use the cost of A, right? What is the cost of reaching to A? And we are then going to add the distance from the node A to the node B, right? So cost of A, initially we have assigned it 0, and so here we are at 0 and the distance from A to B is 2. So cost of B is now going to be 2, right? So now what I can do is instead of maximum infinite, I am going to assign it as a cost of 2, and similar thing we are going to calculate the cost of C, right? The cost of C is actually from the Ath node to the C node, so 0 plus 4 will give us 4. So I can simply do this, right? So that's the idea of Dijkstra's algorithm. We are actually going to use this cost to find which node to explore, right? So out of these two neighbors, which is the third step, right, find the minimum cost neighbor, right? This is the step number 3, a very important step. And here so we have B and C. Out of these two, you can see B has a lower cost, which is 2. So minimum cost neighbor out of 2 comma 4 is actually going to be 2, which belongs to the node B, right? So now we are going to ignore C and now we are going to explore the node B. And so we know that at this point we have the neighbors of again we are going to follow these steps, right? So now for B, I'm going to write here, for B we are going to first calculate the neighbors. So for B we have the neighbors D and C. Okay, so we have these two neighbors and A is also the neighbor, but remember, once we have calculated the minimum cost neighbor, we are going to add another step 4 here, which is mark the node A as visited, right? So we are actually going to maintain a set visited, which will initially be empty set, but now we will add a node to this visited array. Now once we have added it, we are not going to consider it as a neighbor of B because we have already calculated the cost for that. So now these two D and C are the neighbors of B, right? So now we need to move to the step number 2, which is to find the cost of C and cost of D, right? So cost of C is calculated as cost of B plus distance from B to C, right? A very simple formula. So cost of C is equals to cost of B plus distance of this, and now you can see that cost of B is actually 2. So I'm going to write here 2 plus distance from B to C is actually 3. So this will give me a result 5, right? So cost of C is going to be 5. Now you can see here that C already had a value of 4 and this value which we have calculated now is 5, and we can see that here we need to do actually a comparison, right? So 5, which we have calculated the cost, is greater than 4, so we are not going to assign it the value, right? So I'm just going to write here not assigned. The reason we are doing this is because when we are actually calculating this cost is actually the cost of B, which actually takes a path from A to B, and that's why we got the cost 2, and from B to C we have 3, right? So the cost is 5. So this comparison basically says that instead of choosing the path from A to B to C, which is actually 5, we are not going to reassign this value of 4 to 5. We are actually going to keep this value 4, which means that A to C is actually lesser, so that's why we will not assign it, right? So this comparison is also very important, and we will do that here also. If you can see here, A has a distance of 2 from B, so infinite value is actually greater than 2. So whenever we get a value lesser than the cost assigned to any particular node, we can reassign it, right? So that's the basic criteria of assignment, right? So I'm going to write here that this comparison is basically used to do the assign work, right? So now we have assigned this, you can see 5 is greater than 4, so we are going to keep the value of C. Now let's move on to the D. You can see the cost of D will be 2 plus 8, which is 10. 10 is you can see 10 is less than infinite, right? And this is actually for the node D. So since 10 is less than infinite, we are going to assign the cost 10 here, right? Because that's the comparison criteria which we will write in the algorithm. And now what we will do is, out of these two neighbors, we will have to find out, which is step number 4, which we have to do is find out the minimum cost neighbor, right? So out of C and D, you can see that the minimum cost is C, right? It has a value of 4. 4 is less than 10. So now what I'm going to do is, the fifth step is to insert the element inside of the visited array. So now visited array already had A, and now we are going to append B to this visited array. And now we have the C and D. So now we are going to visit C. So for C, right now I'm going to write for C. I'm again going to follow the same steps. So now instead of writing these steps again, I'm just going to follow the steps. So for C, I have these neighbors, which is A, B, D and E. A and B are already in visited array, so I'm not going to visit them. D and E are not in the visited array. So now what I will do is, I will calculate the cost for D first. So the cost will be 4 plus 2, which is 6. And you can see 6 is less than the cost of the node D, right? For that, I can just write 10 is greater than 6. So what I will do is, I will assign this 10 as a value of 6, because that was our criteria of assigning, right? Which you can see here. So now this D node has 6, and it basically means that 6 is actually the distance from A to D, right? You can see if I go from A to C, the distance is 4, and from C to D, the distance is 2. So it is 6, right? So this 6 represents that the path taken is from A to C, right? And now we will do the same step for E. For E, we have C is 4 and this distance is 5. So 4 plus 5 is 9. 9 will be assigned because it is less than infinite. And now we are actually going to mark C in the visited array. So C will also come here. And now out of D and E, which one is less? You can see D is less. So D will be now evaluated. For D, we have these two neighbors E and F. And from here, 6 plus 22. You can see the value is 28, which is less than this. So I will assign it here. And from D to E, you can see I have a distance of 6 plus 11, right? So 6 plus 11 is 17. And since 17 is greater than 9, I'm not going to reassign it, right? So I'm going to leave it as it is. And now this D will be moved to the visited array again. Now we will have to find out which one of them is minimum. You can see this E is minimum. So I'm going to evaluate E now. So E has only one neighbor, which is F. The cost will be 9 plus 1, which is 10, right? And 10 is less than 28. So we are going to reassign the value of F to 10. So the value, this is the terminal. Now we have reached the terminal and the cost at the terminal is 10, which says that that the path taken was from E to F, and E has a cost of 9, which we have got by moving from path E to C to E, right? So A to C is 4, C to E is 5, which is 9, and 9 plus 1, 10, and you can see this is actually the shortest path, right? So that's how this Dijkstra's algorithm works, by considering the cost, and comparison is important here. We are going to assign the cost only when the comparison condition is true, and then we are going to find the minimum cost neighbor. Now at this point, you can see in this algorithm, the step number 4 is very important, which is to find the minimum cost neighbor. And at this point, the interviewer can ask you, what is the algorithm you are going to use to find the minimum cost neighbor out of all the neighbors, right? A lot of people can actually use some sorting algorithm. So what you can do is, the idea is to sort all the cost of the neighbors, and then you can just pop out the first element. And for that you will have some time complexity, but there is one more important and a better time complexity wise algorithm which we can use is minimum min heap, right? Or we can say min priority queue, right? So at this point we can optimize this algorithm, which is the Dijkstra's algorithm, and it is a very important step that we use a min priority queue instead of some other comparison and iteration things, because that is going to increase the cost, increase the time complexity of this Dijkstra's algorithm. So here we are going to at step 4 we are going to do the optimization. So basically Dijkstra's algorithm has a lot of application, and you can see from A to F if I want to send a packet. So in networking it has a lot of applications. So if I want to send a packet from A to F and I want to find out what is the minimum path that I can have, I can actually use this algorithm. The second thing that we also need to do in this algorithm is to also find the path, right? We also want to find the path which is the shortest path, right? So we have already find out the shortest distance by using this comparison of cost and calculating the cost. Now the second thing is to find the shortest path from A to F. So the basic idea algorithmically which we can do is using cost, we can also use and maintain another variable which is the predecessors variable, and predecessor is basically a set which will be empty for all of these nodes. And what we are going to do is whenever we assign whenever we do a comparison, we are just going to append the predecessors inside of this set, and for each and every node we will have a set of predecessors of from the starting point A, and this way we can actually get the shortest path, right? So this part will become more clear when we will see and take a look at the algorithm. So let's take a look at the Python program here. So here we have a Python program. You can see this is actually the main function, and this is actually a graph which I have graph representation in the form of a dictionary. So this algorithm that I am going to show here is you will not be able to find this anywhere because I have written it, and it is really very easy to understand. So make sure to watch this video till the end because it is a very important algorithm, and if you will learn this algorithm it will help you a lot, right? So first of all, one important thing which I missed here is that here at step 4, which is finding the minimum cost neighbor, which we are doing at each and every step, is actually known as a greedy approach, right? So this is known as a greedy approach because at each and every step we are choosing a node greedily, right? Our greed is actually to basically find the minimum value. So I'm just going to write here, our greed is to find the minimum distance. Minimum cost is actually basically the minimum distance from the starting node. So at each and every step we are becoming greedy that we are going to find the minimum cost out of all the neighbors, right? So that's one important thing about this algorithm. It uses greedy approach. Alright, so now let's move here. So here we have the graph representation in the form of dictionary, and here we have all the nodes A, B, C, D, E, F, and this is a dictionary of dictionaries. Now you can see A is the key and value is the whole dictionary itself. Now A is connected to B and the distance is 2, A is connected to C and the distance is 4, and similarly for B also we have done the same thing. B is connected to A with a distance of 2, and C with a distance of 3, and D with a distance of 8. Similarly I have done this for all of these nodes, right? So then we have a variable known as source, which is A, which is the starting node. Then we have a destination, which is the ending node. And now we have, I've just made a function call to this Dijkstra function by passing these three variables, which is the graph, this whole dictionary, the source, and the destination, right? So now let's write this, now let's implement this function. Before implementing this function, make sure to import the sys library, which is used to actually assign the infinite cost to all the elements except the starting node. And then we have from heap queue, which is actually a library which will be able to help us quickly implement the heapify function and heap push and heap pop functions. So these are some utility functions. Alright, so now let's move on to the Dijkstra function. The first thing I need to do is to create an infinite value, right? So here what I can simply do is I am going to initialize a value here, which is going to be INF, and this INF value is equal to the sys.maxSize. Max size is it will return the infinite value, right? The maximum value that it can hold. Now we have this infinite value. Now what I'm going to do is I'm going to create a dictionary with a name node data. So each and every node will have a data and it is actually a dictionary. So here you can see for a node we have a dictionary of dictionary. So a will have two variables, one is the cost and the second one is the predecessors. The cost is initialized as infinite and the predecessor set is empty. I'm going to do the same thing with the node B, C, D, E and F, right? So this is actually a dictionary of dictionaries. So each and every node here inside of this graph will have a cost and a set of predecessors. So the predecessors will actually give me the path from the 8th node, which is the starting node, to that node, right? So now what I'm going to do is I will have to make sure that whatever the starting node is or whatever the source node is, I will have to assign the cost of that node as 0, right? So in case of A, I will have to assign this cost of INF to 0. For that I will write this line, which is node data source. Source is going to point to A here because we have passed A here, you can see. So here the cost of this node will be reassigned to 0, right? So INF will change to 0. Now we are going to create a set of visited elements. Initially it will be empty, and now I'm maintaining a temporary variable of the source. So what I will just do is I will keep reassigning this temporary variable, which is the source variable, to the element which is minimum out of all the neighbors, right? So that we can actually proceed the same algorithm, the same steps by actually just changing the temporary pointer, right? So initially it will be pointing to the source, which is A in our case, and then out of B and C you can see minimum is B. So we are going to reassign the temporary variable to this minimum element of the heap, right? Alright, so now we have to create a for loop which runs from I in range 5. The reason why I have written 5 here is that this is going to be completed in 5 steps, which is n minus 1 steps, where n represents the number of vertices, right? So here we have 6 vertices, so I've written here range 5. So it will run 5 times. Now let's move on to the next step. The next step, which is a crucial step, is to find out whether the temporary variable or whether the source is in the visited array or not. So every time we are going to run a loop, we will have to check whether it is there inside of the visited array or not. Right now, if it is not in the visited array, I'm just going to push it inside of the visited array by using visited.append temp, right? So I'm going to append this temporary variable because we are now visiting this variable, visiting this node, which is the temporary node, and when we will visit B, C and other elements according to whichever has the minimum cost, I'm just going to append it inside of the visited array. Now the next step is to create a min heap. This min heap is actually an empty set. Now what I will do is I will create another loop which is actually used to traverse inside of the neighbors of this temp, which is the source, right? So the source initially is A, and if I want to find out the neighbors of A, I can actually do that by writing this loop for j in graph temp, right? So graph is actually this whole dictionary. Temp is the source, which you can see A is going to be the first one. So A has these two neighbors B and C, right? So now what this will do is this loop will go from all the nodes inside of this dictionary which is pointing to this temporary variable a. So the value of j will be b and then it will be c, and when we will reassign this value of temp according to the minimum cost neighbor, then it will be b, and again the value of j will be a, c and d, right? So the reason why we are writing this for loop is to actually find out which one of the neighbors have a minimum cost, right? So here I am going to actually first see whether the neighbor is already in the visited array or not, because we know that if the neighbor is in the visited array, we are not going to calculate the cost of it, right? Then we are going to write this very important step here. So first of all, I will just move it here and let me just resize it. Okay, so here you can see this important step. This step calculates the cost of the neighbor, right? So now let's see how we can do that. Here you can see we have node data. Temp is actually the node which we are currently visiting. So we will see what is the cost of that, right? So if I'm visiting a, I will first calculate the cost of it. So in the formula here, which you can see, I have already written here, first we will have to calculate the cost of a. So a in our case is actually the temporary variable which is actually pointing to the variable or to the node which we are currently visiting. And then we are going to add it with the distance from a to b. We can get the distance from this a to b by using the graph dictionary here, right? So here you can see I have first calculated the cost of the temporary variable which we are visiting. In the first iteration it is a, so it is this whole thing will be 0, right? And then it will be something else, and now we have to calculate the distance. The way to do that is use graph temp j, right? So graph dictionary temporary variable is actually a, so we are here. Now j is actually going to be the neighbor, right? So in the first case the neighbor is b and the distance is 2, so this whole thing here in this expression will be replaced by 2. So 2 plus 0 will be 0, so the cost is 0 here. Now as you can see that this is a for loop, it will calculate the cost of c also. So the cost of c is actually the distance of the temp to the jth position, right, from a to c is actually 4, and the cost of a is actually 0. So 0 plus 4 is 4, right? So 0 plus 4 will give the cost 4. And now what we will have to do is we will have to assign the cost, but remember before assignment we will have to do the comparison, which I have already mentioned here. You can see we will have to compare the values also. So let's see what we are actually going to compare. We will have to compare this cost that I have calculated with the cost which was already existing inside of this node data, right? So here you can see I am actually writing this condition that if the cost that is the newly cost we have calculated here, if it is less than the cost of the neighbor, which is j, you can see it will be b and c. So I will check the cost of these two neighbors and I will make an assignment only when this cost is less than the cost of the neighbor, right? So here you can see I have done this assignment. So this node j cost means that the cost of neighbor, right? So j is actually neighbor. So b will be assigned a cost of 2 and c will be assigned a cost of 4 after the first iteration, right? Now let's move on to the next step, which is to calculate the predecessors, and predecessors will actually give us the list of all the neighbors which we have calculated the cost of, right? So it is actually the path. So node j comma predecessor basically means the predecessors of j, right? Predecessors of b and c. J is neighbor, so we are actually calculating the predecessors of this. So we are going to assign the predecessors only if this condition evaluates to be true, right? So if the cost is less than the cost of the neighbor, then only we are going to assign the predecessors, and the predecessors will be assigned in this fashion. we will first we will first find out what are the predecessors of the node that we are visiting, which is the temp node. So A initially has no predecessors, so then we will add it with the list of the list of temp, right? Temp is actually just the node which we are visiting, so it will convert it inside in a list form, and then only we will be able to concatenate these two lists. So list of temp is actually A in the first iteration, and A will be appended to this empty list, and B here, which you can see is the neighbor. After this assignment, B will have a predecessor of A inside it, right? So when we will move on to other neighbors, we are going to again see the cost, and we are going to append the predecessors of the temporary node with the actual node where we are at, right, which is the temporary node. We are going to push it inside of the predecessors. Now let's move on to the next step, which is to create a heap, right, which is a very important step. So for each of the neighbors, I'm just going to push it inside of this min heap. So here I'm using the heap push function. What we need to do is we will pass it the min heap. Initially it is empty, right? Then I'm going to pass it two values. The first value is going to be the cost of the neighbor, right? So we are actually pushing the cost of each and every neighbor inside of this for loop. You can see we are visiting the neighbors B and C, so I am appending the cost of B and cost of C inside of this heap by using this heap push function. And what it does is, by default, it is going to actually create a min heap, right? So node data will have this. J is actually the neighbor, right? So we will have the two details. First of all, after this heap push function will push the cost of the neighbor, it is also going to push the neighbor which is J, right? So the heap will look like this after this iterations. You can see we have B and the C node. So the cost is 2 and 4. So 2 and 4 will be pushed inside of the heap, and they will also have this J variable, which is B and C, right? So you can print this min heap at this next step to find out how this heap will look like. Now to find out the minimum element, we will first have to heapify this min heap, right? So we have pushed this all the neighbors with the cost, right? So this is the cost and J is the neighbor. So I have pushed these two data inside of this min heap, and now I am using the heapify function, and by default this heapify function is going to create a min heap, right? So that's an important point. Now what we are going to do is, now we have got the min heap. Now the 0 comma the 0th position will actually give you the minimum element of this min heap, and the 1 is actually going to represent the second variable, which is here. So this 0th variable is actually the cost. So here we will get the cost, but we do not want the cost, we actually want to do a reassignment. So we will have to reassign the temp to the minimum cost. So minimum cost out of B and C is actually B. So this will have we want to give this J variable here, right? We want to actually assign temp equals to B, right, not the cost, so that we can actually proceed with the algorithm in such a manner that it can check whether it is inside the visited array or not, right? For that, what we can do is we will first write min heap 0 and 1, right? So 1 will give me the neighbor, which is J, right? So after the first iteration, when we have calculated the minimum element out of B and C, this statement will assign the value of temp equals to B, right? So 0 is the minimum element and 1 represents the neighbor, which is J, right? Now let's move on to the next step, which is basically just printing out the shortest distance, and the shortest distance is going to be the distance, the cost at the destination position. So you can see the cost at the destination position will give me the shortest distance, and similarly the predecessors will give me the shortest path. So here you can see I'm just converting it to the string, because here you can see we have destination and I will just use the predecessors. Now remember that it will just give me the predecessors which comes before the element before the last element. So I'm just going to append the last element inside of this answer here, which is list of destination, and now this will give me destination, path, and the shortest distance. Alright, so I'm going to write Python 3. The name of the file is Dijkstra, and you can see here we get the shortest distance 10, and the path is A, C, E, and F, which is the correct answer. So A, C, E, F is the shortest path, and the distance is 5 plus 4 plus 1, which is 10. So in this way you can see we have got this output. This whole code I will give it inside of our website. You just need to go to our website and data structures in Python course, and you just need to find out the Dijkstra's algorithm, and there you will see this whole code which you can see here, and then you can try this out yourself. So that's all for this tutorial. If you have liked my efforts, make sure to like this video and also subscribe our channel, because I keep creating these awesome tutorials for you guys. So that's all for this tutorial. Thanks for watching.